Hi folks, so this is the binomial theorem. If you just have a look at these questions here, this with the brackets around them, I just want to go over this first because you need to be able to understand this in order to be able to do the binomial theorem. So I'll just do a simple one. If so 4 and 2 like that. So the way you read that is it's 4 choose 2. That's what it means when you've got brackets around it and you don't have a line in the middle or anything like with fractions. So what it means is if you take 4 of anything, so there could be just 4 objects, there could be apples or they could be coins or there could be anything, alright? If you take 4 of them, it means how many ways are there of choosing 2 of them. So if you were to think how many different ways could I choose 2 of them. So you could have that one and that one, that would be one way. Then you could have that one and that one, that would be another way. You could have that one and that one, that's 3 different ways of choosing 2. You could also have that way and that way, that's 4 different ways. You could have that way and that way, that's 5, and then there's one other one where you've that one and that one. That's all the different ways of choosing 2. I didn't leave any out there. So there's 6 different ways. If you have 4 of anything, there's 6 different ways of choosing 2 of them. So the answer to that would be 6. 4 choose 2 is 6. That's the answer. These ones here are a little bit harder. So 7 choose 4. So if you had 7 objects, so how many different ways of choosing 4 would there be? So I'm not going to go through all of these because there's loads of them. So you could have 1, 2, 3, 4. That's the first way. So that's one way of choosing 4. Then another way would be that one, that one, that one, that one. That would be another way. Another way would be that one, that one, that one, and that one. Alright, so you see there's loads of different, and if I was to keep going there, it'd take me a long time to do it. So luckily there's a way that you can just do it on the calculator, and it simplifies it, but that's really what it means. So there's a button on your calculator, and it looks like this. So it has a little n, and then it has a big C. Let's try to do that again. And then it has a little r, so it's NCR. Try to draw that a little bit clearer. So it's a little n, a big C, and a little r, so it's N choose R really. And so you'll need to find that on the calculator. So on the calculator I have here in front of me, it's just above the dividing sign. So you'd need to, on this calculator, you'd need to press shift and the dividing sign, and that brings up choose. So when you're putting it in, if I was to put in this one up here, this 7 choose 4, what you press on the calculator, you just press 7, and then you'd press shift and the dividing sign, or wherever your N choose R NCR is. So 7, that button, and 4, and then press equals, and it gives it to you. So the answer to that, you should get 36. The next one there, 6 choose 2, you should get 15. 6 choose 4, 6 choose 4 will actually be the same. You get 15 as well. So 6 choose 2 and 6 choose 4 are the same thing. I won't go into it in more detail, but so 15 choose 4 is actually 1365. So there's 1365 different ways of choosing 4 if you have 15 of something. So thankfully that button exists on the calculator because it saves you that much work. And then 10 choose 9 would just be 10. It's the same as 10 choose 1. So that's what it means. That's that. Let's look at the binomial theorem now. Okay, so you'll see in here anyway, though that kind of notation exists, is n choose 0, n choose 1, n choose 2, and up to n choose r. So that exists. Now it looks complicated here in that orange box. It it's hard to understand. Maybe I'll just go through an example. So this n choose 0, n choose 1, n choose 2. The n is whatever the power is. So the first thing you need to look at when you're doing this question is just look at the power. So in my one here, it's 6. So I'm going to start off with 6 choose 0, 6 choose 1, 6 choose 2. And I'm just going to lay it out like this. So 6 choose 0, 6 choose 1, 6 choose 2, 6 choose 3, 6 choose 4, 6 choose 5, and 6 choose 6. And then I'm going to put a little plus in there like that. In front of each one. So that's my first step, because you can see in it it's repeating. That's just what you have to do. You just go up to to 6 choose 6 or whatever your power is. So the question anyway, you're expanding out p plus q to the power of 6. So really that's just p plus q, p plus q, p plus q, and so on, okay, up until you have 6 of them. So you have to multiply them all out. So you could just multiply them all out as normal, but the idea, just multiply the first two first and then multiply whatever you get by the next one and keep going till you've done all 6. But the point of the binomial theorem is it just gives you a different way to do it, and probably a little bit easier, I'd say. Look back up the general rule here. So the next thing I do is I take the first term. So in that one it's x, alright. In my one down here in the example, it's p. So I'm going to take that and I'm going to put it in here, and that will get raised to the power of whatever n is. Okay, so n was the power, remember. So that's 6. And that's then going to be multiplied by the other term. So the other term is q, but the power on q will be 0. So that's just the way it is. Then what happens is, my next one, I'm going to put in p again. So I'm going to put in the first term each time, but now the power will drop down by 1, and that's one of the key things here. So it was p to the power 6 in the first one, now it's p to the power 5. The other term, the q, in the first one it was q to the power 0, so therefore it's going to be q to the power of 1 here. So the power on the second one goes up by 1, and that's going to keep happening. So here I'll have p to the power of 4, the power of p has gone down again, and I'll have q to the power of 2 because it's going up by 1. Here p to the power of 3, and q to the power of, well, it was 2 the last time, so it's going up by 1, so it's 3 this time. P to the power of 2, and then q to the power of, it was 3 last time, so 4 this time. And then we keep going. P to the power of 1 and q to the power of 5, and then p to the power of 0 and q to the power of 6. And then that's going to be it. We need to just simplify down each thing now. So we're taking the first term first, so we're just going to simplify all this together. So 6 choose 0, if you can put all this into the calculator now, you can use, so 6 choose 0, so if you had 6 different objects, how many ways would there be of choosing 0 of them? Well, there'd only be one way, so it'd be 1 multiplied by p6, and then q to the power of 0 is just, it's 1. The next thing then, 6 choose 1, that would actually be 6. 6 choose 1, how many ways are there of choosing 1? If there's 6, use calculator, it'll be 6. P to the power of 5 is just p to the power of 5. Q to the power of 1 will just be q. Plus again, 6 choose 2, so you can use calculator for that. It'll be 15. P to the power of 4, and then q squared. 6 choose 3, again use calculator. So you should get 20. P to the power of, I don't need a bracket. p to the power of 3 and q to the power of 3. 6 choose 4 will be the same thing as 6 choose 2, so it'll be 15. P squared q4. 6 choose 5 is the same thing as 6 choose 1, so it's 6 p q to the power of 5. And then my last term, 6 and 6 choose 6 is just 1. There's only one way of, if you have 6 items, there's only one way of choosing 6 of them. So 1, and p to the power of 0 is 1, and q to the power of 6 is just q to the power of 6. So I'll just write it out one more time just to simplify a little bit further. All that in the first thing is p to the power of 6 plus 6 p to the power of 5q plus 15 p4 q2 plus 20 p cubed q cubed plus 15 p squared q to the power of 4 plus 6p q to the power of 5 plus, and the last thing here was q to the power of 6. So that thing up here expanded out would be all of this down here. That's going to be your final answer. So that's it. That's an example. I'm going to do one that's a little bit harder, but actually has less terms in it. Right, so this one's a little bit harder now because it has a 2x and it has a minus 3y. So my two terms are 2x and the other one is minus 3y. So those are the two things I'll be putting in each time. The power anyway is 4. So remember, the first thing we did last time was go whatever that was. So this time it's 4. Last time it was a 6, so this time it's a 4. So 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. Those are all my terms, and then I put the little plus in here because we're adding all these terms together. Now I'm just going to take my first term, which is 2x this time, and I'm going to raise it to the power of whatever n is, so it's the highest power, so it's 4. The other term is minus 3y, and that's going to be to the power of 0 for the first one. Then it's 2x to the power of 3, because I've just reduced it down by 1, and my minus 3y, that gains a power, so it becomes 1. Then 2x to the power of 2, and minus 3y will be to the power of 2, it goes up by 1. 2x to the power of 1, and minus 3y to the power of 3, and then 2x to the power of 0, and minus 3y to the power of 4. So give yourself loads of space with these. I'm kind of scrunching it in there because I didn't give myself enough. Then it's just working it out. So 4 choose 0 would be 1. 2x to the power of 4, so I have to raise both the 2 and the x to the power of 4, so that would be 2 to the power of 4 is 2 times 2 times 2 times 2, so that's 16, and it'd be x to the power of 4. Minus 3y to the power of 0 is just 1, plus 4 choose 1 is 4. 2x cubed would be 8, x cubed, and minus 3y to the power of 1 is minus 3y. So we still have to multiply all of those out. So see, these are harder than the last one. Plus 4 choose 2 would be 6. 2x squared is just 4x squared. Minus 3y all to be squared would be positive 9, because minus 3 times minus 3 is positive 9. So 9 y squared plus 4 choose 3 would be 4 times 2x times, and it'll be minus 27y cubed, because I have to cube the minus 3. Minus 3 times minus 3 times minus 3, plus 4 choose 4 is 1, 2x to the power of 0 is 1 as well, and this minus 3 to the power of 4 will actually be 81 y to the power of 4. Nearly done. So 16x to the power of 4 plus this would be so it'll be minus 96. That's 4 times 8 times 3, and it's a minus 3. X cubed y. 6 times 4 times 9 will be 216. So it's plus 216 x squared y squared. I need to do 4 times 2 times minus 27. So that's also minus 216 xy cubed. And the last thing is just plus 81 y to the power of 4. So that's it. That's what that thing would be when it's expanded out. 2x minus 3y all to the power of 4. So again, what you could do is just multiply that by itself, and then multiply it by 2x minus 3y again, and then multiply by 2x minus 3y again. So just keep multiplying them out, but this binomial theorem just offers a different way of doing it. Right, so I'll just put up another one. Just keep it nice and simple. So we got 3x just minus y, and we'll just go to the power of 3. So if you want to pause the video and attempt that, then you can now, and then play it on, and I'll go through the answer. So my power here is 3. Now this will be a nice simple one. It's only cubing it out really. So it's 3, choose 0, 3 choose 1, 3 choose 2, and 3 choose 3. So put in your plus. So I'll have 3x all to the power of 3, and my minus y to the power of 0. Then 3x, the power goes down by 1, so it's 2, and my minus y is to the power of 1. My 3x then goes to the power of 1, and minus y is to the power of 2, and 3x is to the power of 0, and minus y is to the power of 3. Yep. So 3 choose 0, that'll just be 1. 3x cubed will be 27 x cubed, and then it's just times by 1. Because minus y to the power of 0 is 1. 3 choose 1 is 3. This will be 9x squared, and it's times by minus y. 3 choose 2 will also be 3, times by 3x, and times by, I made a little mistake in there, so that square should really be outside, so minus y squared. So minus y squared is just positive y squared, because a minus times a minus gives a plus, and then you're adding on, so 3 choose 3 was just 1, 3x to the power of 0 is 1, and you actually get minus y cubed there. So minus y cubed, yeah, it becomes a minus, because minus times minus times minus. So 27x cubed minus 27, it'll be x squared y plus 9xy minus y cubed. So that's the way it should look. Yep, so that's it.